Hello children, in this video let us work out the last sum of exercise 2.2. We are asked to find the zeros of this polynomial 3x squared minus x minus 4 and also asked to verify the relationship between the zeros and the coefficients. Now we have to find, in order to find the zeros of this polynomial, we have to find those values of x for which the polynomial itself is equal to 0. P of x is equal to 0. So, in order to find zeros, we'll have to solve for this equation. 3x squared minus x minus 4 is equal to 0. Now, here you have to split the middle term into two terms in such a way that the two terms add up to minus x, but they multiply to minus 4 into 3, which is equal to minus 12. So, they have to multiply into minus 4 into 3. So, let's find the factors of minus 12. So, I think these factors itself, minus 4 and 3, add up to minus 1, which is the coefficient of x here, isn't it? It is the coefficient of x. So, we can use the same factors to split the middle term. So, 3x squared minus 4x plus 3x minus 4 is equal to 0. If we group them in two different groups, we observe that in the first equation, in the first term, x is common to both. So, x, if it is factorized out, we have 3x minus 4, which if you multiply x into 3x is 3x squared, x into minus 4 is minus 4x. And the second group is, if 3x minus 4 is kept as within the brackets, plus 1. 1 is common to both of them. There is no other factor common. So, you have all these equal to 0. So, when will this be equal to 0? Either when x plus 1 is equal to 0 or 3x minus 4 is equal to 0. Right? So, let us go ahead and find the zeros. So, one 0 is at x plus 1 equal to 0 and the other 3x minus 4 equal to 0. So, the value of x will be either minus 1 or x is equal to 4 by 3, but both, isn't it? Now, for verifying the coefficient, the relationship between the zeros and the coefficients. Now, this equation is in the form ax squared plus bx plus c, right? It's in the form 3x squared minus 4 is in the form ax squared plus bx plus c. So, what are the a is equal to 3. These are the coefficients. B is equal to minus 1 and C is equal to minus 4. Now, what is the relationship between the zeros and the coefficients? If alpha and beta are the 0, alpha plus beta should be equal to minus b by a. B by a in the sense coefficient of x by coefficient of x squared. And alpha beta should be equal to c by a. C is the constant term by coefficient of x squared. So, let's see if they are true. So, what do you have as roots here? We have found that minus 1 is one root plus 4 by 3 another root. You add both, what do you get? You take the LCM of 3, so this is minus 3 plus 4, so this is equal to 1 by 3. So, now what were the b values and a values? B was minus 1, a was 3. So, if you take minus b by a separately, now all this is RHS. Whatever we have done was the right hand side, alpha plus beta. So, let us draw a line here. Let us draw a line here. So, this is the left hand side, minus b by a. Let's see if they are equal. We found that b was 3 minus 1 and a was 3. So, minus of minus 1 by 3, which is equal to 1 by 3. So, now the RHS and the LHS are equal. So, the relationship alpha plus beta is equal to minus b by a was found to be correct. It's verified. Now, what about alpha, beta and c by a? So, let us also split it here as two different sides, RHS and LHS, and find alpha beta first. Alpha beta is minus 1 multiplied by 4 by 3, which is equal to minus 4 by 3. And what about C by A? See, your C was minus 4 and A was 3. So C by A is minus 4 by 3. And both of them are found to be equal. So our other relationship between the products of the roots alpha beta is equal to C by A is also verified and is found to be correct. So I hope you followed the video. Thank you.